This review was prepared by Federico Iannacci and Sasha Kraus and published by TheoryHub. TheoryHub covers a wide range of theories and acts as a starting point for theory exploration in different research and teaching and learning contexts. This is a review of the configurational theory. Configurational theorizing is about transcending the qualitative-quantitative divide by formulating formal statements explaining how causally relevant conditions combine into configurations associated with the outcome of interest. Configurational theorizing shifts researchers' attention from the assessment of the net effects of causal variables to a more contextual understanding of the multiple possible ways in which causal conditions may combine to produce a given effect. Configurational theorizing revolves around three tenets. The first is conjunctural causation, postulating that the effect of a single condition unfolds in combination with other conditions. The second is equifinality, which means that multiple configurations of conditions may lead to the same outcome. The third is causal asymmetry, which means that the causes leading to the presence of an outcome of interest may be quite different from those leading to the absence of the outcome. According to Des and colleagues, a configuration contains relationships among elements or items representing multiple domains. Therefore, configurational theorizing moves the theoretical discourse forward because it is not confined to the study of net effects. For example, linear regression examines the net effect of a variable on the outcome by holding other variables constant. Configurational theorizing instead studies the holistic effect stemming from a configuration of causal conditions. Qualitative comparative analysis is probably one of the most formalized configurational, comparative methods that relies on Boolean algebra rather than linear algebra, the logic of implication rather than covariation, and conjunctural causation rather than simple interaction effects. Configurational theorizing is premised on the assumption that configurations of causally relevant conditions should be linked to the outcome of interest. Since the focal unit is the configuration, it follows that a given condition may have a different effect on the outcome depending on its combination with other conditions. This notion in turn fits with the idea of causal complexity. It implies that a causal condition may have opposite effects depending on its combination with other conditions, so much so that the same condition may contribute to the presence of the outcome when other conditions are present, but it may actually contribute to the absence of the outcome when other conditions are absent. As a result, the researcher is urged not to specify a single causal model that fits the data best. This in turn will spur researchers to discover multiple causal models that involve conjunctions of three or more conditions, thus moving beyond second-order or third-order interaction terms. Configurational theorizing revolves around the six principles. The first is that configurational theorizing is based on sets, that is, groupings that entail membership criteria and have classificatory consequences, while standard statistical techniques are based on variables. For example, male is a set that invokes a group of individuals, whereas gender is a variable. Likewise, Swedish is a set that invokes a particular group, but nationality is a variable. By the same token, degree of democracy is a variable, but democratic invokes a set such as the group of democratic countries. Sets are not simple nominal scale classification because observations can vary in the degree to which they satisfy membership criteria. For example, a country can be a full member of the set of democratic countries while another country can be a full non-member of this very same set, and yet another country can be neither in nor out of the set of democratic countries. The second principle is the usage of calibration rather than measurement. Standard statistical techniques are based on variables that are measured by using valid and reliable scales or indicators. Observations are evaluated relative to one another, based on inductively derived, sample-specific statistics such as the mean and standard deviation. For example, a high score is well above the mean score, a low score is well below the mean score. All variations in an indicator are usually treated as meaningful and taken at face value. To this end, calibration is the process by which set membership scores are assigned to observations on the basis of external standards. For example, taking the uncalibrated variable of per capita gross national product, it is possible to calculate membership in the set of rich countries by using three external standards. They are the score that would qualify a country as a full member in the set of rich countries, the score that would qualify it as a full non-member in the set of rich countries, and the crossover point. The third principle is the focus on qualitative outcomes instead of dependent variables. Standard statistical techniques revolve around dependent variables, so that the goal of research is to explain cross-case or a longitudinal variation in the chosen dependent variable. Configurational theorizing instead focuses on qualitative outcomes, that is, observable changes or discontinuities. For example, instead of studying longitudinal or cross-case reduction in welfare spending, analysts should first define the concept of interest and then calculate the country's membership in the set of countries experiencing welfare state retrenchment. The fourth principle is the focus on constructed populations rather than given populations. Standard statistical techniques use either given populations or random samples from these populations. Instead, configurational theorizing entails constructing populations in the course of the investigation, by comparing both the presence and absence of the outcome of interest. The fifth principle is studying set relations rather than correlations. Standard statistical analyses are based on correlations. Correlational arguments are symmetric arguments. Configurational theorizing, on the other hand, is based on asymmetric set relations. For example, the assertion that the developed countries are democratic does not require that the not developed countries be not democratic. There can be many not developed countries that are democratic, and their existence does not count against the initial claim, which is asymmetric. Accordingly, standard statistical techniques pass matrices of bivariate correlations or their mathematical equivalents. Instead, configurational theorizing uses truth tables that list different configurations of causally relevant conditions. The final sixth principle is the focus on causal recipes rather than net effects. The standard statistical template revolves around net effect thinking. The net effect and statistical significance of each causal variable are based on its unique contribution to explained variation in the dependent variable. As such, configurational theorizing is about how individual conditions combine to produce the outcome of interest, thus helping analysts formulate causal recipes that will lead to the outcome of interest. These recipes can be evaluated on the basis of their theoretical and empirical importance. Although conditions are oftentimes selected in a deductive manner when deploying configurational theorizing, it is possible to evaluate such theories by looking at the extent to which theoretical expectations overlap with empirical results. While the focus of standard hypothesis testing is to reject the null hypothesis, the focus of theory evaluation in the context of configurational theorizing is to evaluate hunches derived from theory. This is done by creating intersections of the Boolean expression describing the theory and the empirical solution. Configurational theories have recently been updated with the use of set-theoretic multi-method research. In other words, configurational theorizing becomes stronger when researchers add within-case evidence to bolster their understanding of causality. Scholars have developed a trajectory-based configurational approach that conceptualizes configurations dynamically, so that they express different development stages. Accordingly, scholars can now track qualitative variations occurring within single cases over time in order to show how cases can switch from one configuration to another configuration. Other approaches refer either to panel data or to time series. Whereas panel data approaches provide some diagnostic tools to assess a set-theoretic consistency and coverage both cross-sectionally and across time, time series approaches incorporate time series variations. Configurational theorizing has attracted criticism with regard to its relation to complexity theory. For example, it is not clear whether, and to what extent, the three pillars of conjunctural causation, equifinality and asymmetric causality closely correspond to propositions underlying systems theory and complexity theory. Another issue that has attracted significant criticism pertains to the solution being chosen. Although core texts have advocated choosing the intermediate solution, some scholars have recently voiced criticism of the intermediate solution by advocating a more parsimonious solution. This debate is in progress and reflects several inconclusive aspects of the current state of the art. In particular, it is characterized by the use of different criteria for evaluating the solution types, implicitness about these criteria and the required background assumptions for drawing causal inferences, and/or, more fundamentally, different analytical goals used in the context of configurational theorizing. Thank you for listening. To download the full review or to read other theory reviews, visit open.ncl.ac.uk.